To kick things off, we've got a lot of terminology we need to get through. So in mathematics, when we talk about a relation, what we're talking about is the pairing of one set of numbers, one group of numbers with another. What we mean by that is, and you can kind of look down the page a little bit here, is this concept of like inputs and outputs. And how we communicate how these numbers, groups of numbers, are paired together, there's a variety of ways that we can do that. One is through just a list of ordered pairs, so kind of XY coordinates like we see here. So 1, comma 2, that means the number 1 is paired with the number 2, 3 is paired with 6. Another way that we can communicate that same kind of set of information is in a table of values. So here we see we've got 1 is paired with 2 again, 3 is paired with 6. So that's another way that we could do it. We could do that via a graph. Again, we've got the exact same pairs of numbers shown to be related to each other. 1, 2 is the x and y coordinates, respectively. 3, 6, the x and y coordinates of a point on the graph. So we're showing that those are connected to each other that way as well. We can also do it via what's called a mapping diagram. So to be perfectly honest, this is something that you'll pretty much only see in a math class or in a math textbook. But we've got kind of our set of inputs, our initial values, the first set of numbers, showing how it's being paired with the second set of values through a series of arrows that connect those two sets of numbers. We'll look at those a little bit more closely in a moment. And then finally, we could have a relation, show how numbers are connected to each other via an equation. So if I plug in particular values for x, those will generate particular values for y. So when I plug in 1, for example, for x, if I go 5 times 1 and then add 7 to that, I'm going to end up with 12. So we get an input-output pair by plugging numbers in for x and y and generating y values. So there are lots of ways that we can describe the inputs and the outputs, the first set of numbers and the second set of numbers. The formal description for it, the definition of that first set of values, so the x-coordinates here, or the x-coordinates on the graph, or in this first oval here, or the inputs into our equation, that's the domain. So we use the domain to describe that first set of numbers, and then the term range is used to describe the second set of numbers. So the y-coordinates, the y values in the table, the second oval in our mapping diagram, etc. And so you can see all of these terms down below that are connected to each other. So the domain is your inputs, is your x-coordinates, is your independent variable, meaning those are the numbers that we're going to plug into an equation for x to generate the outputs. And so again, range is going to be those y values. We refer to that as the outputs of the relation, the y coordinates, or we say it's the dependent variable because it depends on what we plugged in for x, what we're going to get out for y. So here I just wanted to explore how these mapping diagrams work a little bit more closely. So what you can see here is we have our domain is this first oval, and so we can go ahead and list those numbers off here, 2 and 5. Yes, the 2 is being used twice if we see 2 arrows coming from it, but we don't have to list it twice. It's not wrong if we do, but it's just a little cleaner if we don't. And then the second oval here represents the range. So we've got 3, 5, and 6. And so each of those arrows just represents an ordered pair, an XY pairing. So we could write 2, 3 is the first ordered pair. We've got 2, 5, it's a comma there, believe it or not, is the second ordered pair. And then 5, 6 would be the third ordered pair that's being described there. In the second example, where we have the graph of these 4 points, we just have to make sure that we list off the x and y coordinates. So maybe we'll start with the ordered pairs and then work to the domain from there. So if we start on the left-hand side with the green point there, The coordinate is -2 for x. We're moving 2 units to the left, which is the negative direction, but then we're moving up 3 units in the positive direction for y. So -2, 3. If we just keep on moving from left to right, so go to that purple dot that's right on the y-axis. So the coordinate there for the x-coordinate is 0, because we haven't moved left or right at all, but then the y-coordinate is -1, because we've moved down 1 from the origin, from 0, 0. Our next point, the red one, is we're going over 1 and up 2. So we've got that point, and then finally the blue one, we're over 2, and then we're up 3. So we're just counting from the origin every single time. And so then the domain is just going to be the collection of the x-coordinates that we see there. So I just look at each of these x-coordinates, and I'm just going to list them off one at a time. So -2, 0, 1, and 2. And then for the range, we're just going to label up all of the y-coordinates. So I'm just going to underline all of those there. So we've got, if we want to put them in numerical order, we can see the smallest of those numbers is -1. Then we've got 2 is the next largest number. And then the y-coordinate 3 appears twice. So again, it's not wrong if we list it twice, just a little bit cleaner if we don't. And then writing them in order from least to greatest, unless we're specifically told we have to, isn't a necessity, but it can be helpful for us to determine what those values are.